Initially, modeling with functions. We are looking at being able to take various formulas and stuff we've learned over the years, okay, or we've kind of learned to understand over the years, and being able to work with them, okay? Several different scenarios, whether it's figuring out what formula to use for a problem or whether it's figuring out how to solve a formula, but various pieces of using formulas, okay? Now, for the most part, these are formulas technically I would say you should know or be very familiar with, okay? So, in example 1, they're going to ask us to write the area of a circle, and it's as a function of its, and we're going to write the area of a circle formula in 3 different ways, okay? When they ask us to write the area of a circle function as a function of its radius, that means r, radius, is going to be your variable in the formula. When we move on to writing area of a circle as a function of its diameter, that means r is going to have to be equivalated, and we're going to have to use d for diameter. And then we're also going to look at writing it as a function of circumference. So when it says as a function of, like that would be what your input is. Okay, now, let's start with A. What do you know about area of a circle as a function of its radius?
I couldn't even tell you what the area of the circle is right now.
That's a problem.
I know.
4 over 3.
Is it like
pi r squared?
Pi r squared.
You guys are way overshooting this.
Which one is the 4 over 3?
That has to do with volume.
yeah, right.
That has to do with volume of a sphere, 4/3 pi r cubed. That's the only one I can think of with 4/3 at least. Okay, guys, so what you should know, notice you're not alone if you don't, area of a circle. Area equals pi r squared. That is a formula, folks. You've hit pre-cal level. You just need to have it memorized and know it. It's a fact of life at this point for you guys. Okay, so anyways, now, nice part about this one, we wrote the area of the circle, so A equals, what's the variable in there?
R.
R. So we wrote the area of the circle as a function of its radius. Okay, we're done with part A. We're done with part A because the area of a circle, the formula we know, is based on the radius. Now, they want us to write the formula for area of a circle again, but this time as a function of its diameter, which, if I put this shortly, you're not allowed to have R in the formula.
So it would just be pi d.
Not exactly.
But the diameter is. Yeah.
Do I have to do like pi d over 2 squared?
We're hitting the right. You see, okay,
Yeah,
so
I see.
okay, so you have to think about how this works. So here's what I'm going to say. We need to be able to put a D in there, right? I don't know how your brains work, but my brain goes to the fact that, and your brain probably just went to the step. True fact. 2 times the radius is equal to the diameter. Yes?
Yeah.
That's fact we can all agree with. Now, I need to be able to, when I see an R, replace it in the formula. Well, what is R equal to? R is half the diameter, or could I say D divided by 2? You could say 1/2 D as well. And so now the idea is take this formula over here, which is what you guys were working to do, and replace it. So this is pi times, what am I using for R? D over 2 quantity squared. Now, I would encourage you to clean that up a little bit. This isn't wrong as it is, but it can simplify a little bit. What do you know about, what are we going to get when we do D over 2 quantity squared?
Just d squared over 4.
I like D squared over 4. That's squaring top and bottom, right? Okay. Now, this is equivalent to a final answer. It's all equivalent to a final answer. Personally, how I'm going to write this, okay? Bless you. Pi is a number, yes? Okay, so pi is a constant, it's not a variable. Pi is a number. 4 is a number, whereas d squared is a variable, yes? Two different ways I could see to write it. I'm going to choose to write it as pi over 4 times d squared. Where what have I done? I've taken my constants and put them out front times the d squared. The other way I could see doing this is saying pi d squared all over 4 if you wanted one fraction. Now, have we written the area of a circle as a function of its diameter?
So
Because you'd have to know the diameter to use this formula.
we can't leave it like the second to last one. We have to put them.
This one?
Yeah, we have to put them together.
I'm not going to say you couldn't. I mean, it's equivalent, but it's not very, I don't know, not the best form. It's not, it's still equivalent if you leave it there.
Yeah.
Okay. Okay. One last one. Write the area of a circle as a function of its circumference. So start with facts about circumference.
Isn't that like the whole circle?
Like the outside of the circle.
Okay.
Is the
So
perimeter
circumference
of the
is the
Whole circle.
distance around the circle. Think perimeter, if you will. I mean, you know, we don't call it perimeter because, you know, perimeter is adding all, but that's what it's equivalent to, right?
Does it have to do something with like 360 or whatever?
Not the circumference formula, no.
Okay.
Isn't it like it has pies in there somewhere?
Of course it has pies in it. It's a circle.
Oh.
2 pi r?
Yes.
Mhm. Or, and I think 2 pi r, what's the other one that you guys are equivalent to?
I don't know.
Anyone you think pi d?
Yeah. That's
Okay. Either way. Okay. So, you could think pi d or 2 pi r, yes. Okay, those are both equivalent, right? Because the diameter is 2 times the radius. Okay. So that's the other one we tend to get mixed all around, circumference and area. I don't know. We can't keep them straight for whatever reason. Now, we need, probably going to use 2 pi r is what I would have said. Okay. We need to know what r is, yes? You need to know what r is to plug it back into the original formula. Or if you really want to, you could solve this one for d and plug it into my formula that involves d, yes?
Yes.
Okay. C equals 2 pi r. If I solve this for r, what is this going to be?
Divided by 2 pi.
Divide by 2 pi. So then you're going to have that r is
C
c divided by 2 pi. It's about as clean as it's going to get. So start rewriting your area formula. Area, I'm going to use my pi r squared, so pi times radius squared. So what's that mean I'm doing? C over 2 pi quantity squared. Personally, I'm going to go ahead and put pi as a fraction. What's pi as a fraction? Pi over 1. What's c over 2 pi quantity squared?
C squared over 2 pi squared or 4 pi. Something along those lines.
C squared over,
4 pi. Wait, no.
4 pi squared.
Yeah.
4 pi squared.
I like 4 pi squared. Okay? Thoughts of how you'd write a final answer here?
Would it be like c squared over 4 pi?
Because what can happen?
You could cancel out the pi.
1 pi on top can cancel with one of the pi's on bottom. So c squared over 4 pi. Okay. That's using all formulas you know, yes?
Yep.
Okay, so it's using formulas you know. You've just got to work to manipulate them. Okay, ready for the next one?
Mhm.
Okay, again, it's going to be using a formula you know. You just have to manipulate it. Example 2. A square of 6, excuse me, that does not say 6. A square of side x inches is cut out of a corner, each corner of an 8 by 15 piece of cardboard. The sides are folded up to form an open top box. Write the volume of the box as a function of x. Well,
Length
Let's-
times width
Times height.
times height.
there we go. Okay, good combo.
Yeah, right.
Okay, so eventually we're going to be talking volume of a box. Volume of a box is volume of a rectangular prism, which is length times width times height, yes? Eventually. Now, the thing is, what are we supposed to do? We're not supposed to have an L, a W, and an H. We're supposed to have
Next.
x's. That's it. That's your only variable we're allowed because it's as a function of x. Now, what do we have here? A square of side x inches is cut out of each corner of an 8 by 15 inch piece of cardboard. Okay, let me get fancy here. Okay, there is my 8-inch by 15-inch piece of cardboard. Yes? What's done?
X inches is cut out from each corner.
Okay, so a square, x inches, so x by x, right? So a square like that is cut out of each corner. And we're just going to pretend these are all squares because mine don't necessarily look very square-like, do they? And we're going to do this with all 4 corners. Okay, so you cut those squares out, right? And then, what do? After you cut those squares out, you're going to fold up those sides, right? You're going to have flaps on each side, and they fold up, and it's going to be an open top box, aka a box without a top. Okay. Thoughts on what we know here?
You need to like find the sides of each corner you cut out.
Okay. Do we know anything about those sides?
No. Oh, we only know that they're X.
Okay. What do we know about the big piece of cardboard?
We have an 8-inch and a 15-inch.
Right?
Could you like divide that or something?
Not going to divide anything. What do we need to know? So this whole piece right here, this whole length is 15 inches, yes?
Yeah.
And what are we going to do? We're going to cut out these corners here, and then those flaps are going to fold up.
So we're gonna do it like 15 minus 2x.
Mm-hmm. Because we need to know basically that length right there now. The whole length was 15. You're taking away an x on each end. So that's going to be 15 minus 2 x's. What's that going to replace? That is my length. Thoughts about the width?
Same thing, but it's going to be 8 minus 2.
Yeah. The whole width was 8, but you take away an x from each side and it's 8 minus 2x. And that is your new width. So, where am I at here? Volume equals length 15 minus 2x times width, 8 minus 2x times height.
X.
Yeah.
Because where is the height?
It's nowhere.
It comes from folding up these flaps, yes?
Yeah.
How tall are the flaps?
X.
They're x tall. So times x. I must be thinking of algebra 2 or something, because I was thinking we were going to multiply this out, but my notes, leave it right there. Okay? I mean, if we were going to multiply this out, what do we need to do?
Foil.
We need to FOIL, yes? You'd FOIL your two parentheses and then distribute the x. Okay. That's using formulas you know, yes?
Mm-hmm.
Volume of a box, I expect you to know that. Okay. Ready for the next one? Okay, let's talk about Mark. Mark received an 8.5% salary increase. I wish. His salary after the raise was $36,890. What was his salary before the raise? Okay, I'll take that increase. I don't want that salary. Okay.
Can we do them with the 36,000 and the 8.5?
Yes.
We're gonna take the 8.5 out of percent.
Okay. So if we're going to be working with the numbers, if we're going to be working with setting up an equation, 8.5% should probably be changed to
0.85? Nope. 0.085?
honestly, I didn't catch the first one, so I know the second one's right there, though.
Well, wait.
Okay. Now, he has an 8.5% salary increase. His salary after the raise is $36,890. What was his salary before the raise?
Do we multiply?
You multiplied the salary after you got the raise by 0.085, and then you take that number and subtract it from the number or his salary after the raise.
No. So here's the problem with that. I mean, I'm hearing some of the right steps, but we're not using the right pieces at the right time. His salary after the raise is $36,890. 8.5% of that is not what his raise was.
Oh,
Because his 8.5% salary increase is based on
what?
the original. What is his original? What could we call his original?
X.
Let's call his original X.
X times 0.085 equals 36,890.
Closer.
Hey.
Okay, so if we do 0.085 times X, that is 8.5% of his original salary. Is 8.5% of his original salary just going to equal his new salary?
No.
No. What do you have to do?
Add it to
Plus X. Yeah, right? Yep.
Okay. Is this making sense? His original salary is X, plus he's getting 8.5% increase. So 8.5% of his current salary he's adding on, and he's going to end up at $36,890. Now, what is X plus 0.085X?
Would be like 1.085X.
Mm-hmm. Now, some people would call me silly for going through that first step, but I needed you guys to see that first step. Some people would say, oh, I'm just going to jump right here. 8.5% salary increase is you're now earning 108.5% of what you were earning. So could you just jump to this equation right here? You could. How do I solve? Divide. It's obviously a calculator problem. What do the calculators say? least I hope that's what it says.
34.
34,000? I made the numbers come out nice. Now, to check yourself, could you take that 34,000, multiply it by 8.5%, and then add it back to 34,000? Yeah. Okay. The other part of this is separate, and I know the bell's going to ring on me, unless you know exactly what you want to say right there. But cost of an item after a 45% decrease. We'll talk tomorrow. I would like to say you might get a little bit of work time tomorrow.
That'd be awesome.
But you're not gonna say it because you know if you do, then